I think in the last class we were talking about the TCP congestion. So before discussing this TCP congestion, let me just go back and check it out. I think we have done this one, right? The ATM ADR, the asynchronous transmission. Okay. Now, if you go on talking about this, the TCP congestion control, that is the additive increase and the multiplicative decrease. So here, if you take this example, just go back to the scene, the scenario of this. There are 4 hosts are there: host A, your host B, host C, and host D. Okay, and consider there are 4 routers are there. So now here, what is we need keep in mind. Here, treat this is as router 1. This is as your router 2. This is your router 3. And this one is your router 4. Is my voice is audible? Okay. So then in the first place, if you go through this TCP, what is this? Saying that the congestion in additive is then multiplicative decrease case. So what is this approach? The sender increased transmission rate, that is having the window size. So for that, what they are using, the probably for your usable bandwidth. So how it is happening? Let us see here. There is a transmission between your host A to host C, and that transmission is represented as your red line, right? Host A is sending the packet via your router 1, router 3, and it will reach to host C is 1. Okay. Similarly, your host B is transferring the data, suppose, to whom host B become the source and host D become the destination. So where you can find the green line. So here you can see host B is transferring the data via router 3, router 4, and it will reach to your host D. Correct? And then if you talk about the host C is transferring data as the host C is the source and host A is the destination. So you can see the pink line. So host C transfer data via your router 4, then router 2, and then it reaches to your host A. Similarly, your host D also. So now see the assumption here is, let us consider in this network for an instance time, only host A and host C are going to be communicate. Okay? Are going to be communicate. Rest host means host B and host D are idle. So क्या होगा यहाँ पर? You just see in the assumption that whatever the red line capacity is there, a red line is there which is connecting your host A and router 1. Okay? And router 1 connected to your router 3. And router 3 is connected to your host C. Okay, so as per the congestion scenario, let us assume that the host router 1 is having unlimited buffer. Similarly, router 3 is also having unlimited buffer memory. Okay. Second condition is the input line. The input capacity of your router 1. Input line means this part, right? The input line of your router 1. The input line of your router 1, assume that 10 Mbps speed. Okay. The output line capacity also 10 Mbps. So here you can see the output of your host A, the output line of your host A is given as an input line of your input line of your router 1. The output line of your router 1 is given as an input line to your router 3. So assume that this line capacity is also 10 Mbps. The output line of your router 3 is given as an input to host C. Okay. So the input capacity of your router 1 is 10 Mbps. Output capacity is also 10 Mbps. And input capacity of your router 3 is also 10 Mbps. And output capacity of your router 3 is also 10 Mbps. And input capacity of your host C is also 10 Mbps. Okay. Memory is unlimited at router 1 as well as your router 3. Memory is unlimited. Okay. So in the first case, so online side, is it clear? Are you getting the voice and the explanation clearly? So now up to this point is clear, right? Okay. Then what happens in the first scenario? Only host A and host C are trying to transfer or exchange the information or exchange the data. So in this case, host A becomes the source and host C becomes the destination. Or host A is the sender and host C is the destination. Correct? Okay. So then host A started transferring the data. So as per TCP scenario, what happens? As per TCP scenario, what happens? There will be a connection establishment process. So in the connection establishment process, TCP follows three handshaking. In three handshaking, host A and host C, they are exchanging certain information via the special TCP segment file. What is this information? At what rate host A can transfer the data? At what rate host C can receive the data? How much data the host A wants to send and how much data host C able to receive. Correct? This is some kind of what kind of checksum is used by your host A, and the same checksum is informed to host C for the error checking purpose. Correct? What is the port number used by your host A, and what is the port number used by your host C? So these are some parameters which are exchanged in between your host A and host C during the three handshaking process. Clear? So as we know, the maximum size means input capacity or the output capacity of your host A is 10 Mbps. The maximum input capacity of your host C is also 10 Mbps. Okay, so once the three handshaking is done, now host A is started transmitting the data. Why? So here this red line shows that one. Host A is transmitting the data. So in the initially, host A is saying that host A starts with the 2 Mbps speed for the first attempt, 2 Mbps. So that 2 Mbps are received by your router 1 because router 1 is directly connected to your host A. Correct? Now router 1 receives the 2 Mbps and what is the router 1's input capacity? 10 Mbps. So 2 Mbps is not a big matter. So router 1 receives that 2 Mbps data and keeps that data for a while in your buffer. Why? Because router 1 checks the header field of the data, the segment. What is the source port number? What is the destination port number? But here router 1 is the network device, so it will check the source IP address and the destination IP address. So as soon as checks the destination IP address, it finds a route of your output line and it will connect to your router 3. So that process happens. So that goes from 1 to 3. Then router 3 also do the same thing. It receives the 2 Mbps data from router 1, which is coming from your host A, and it will store in its buffer and process it and forward it to the host C. Right? So in three handshaking process, host A and host C agreed that at 10 Mbps data host A can transfer, at 10 Mbps data host C can receive. So only 2 Mbps data came, that means it is acceptable, and they can, without any problem, they receive. So upon receiving the 2 Mbps data, host C can generate the acknowledgement. It may be the positive acknowledgement, it may be negative. But only 2 Mbps data is there means definitely there is a positive acknowledgement, because TCP provides the reliable data transfer, correct? So that positive acknowledgement go back from host C to whom? Router 3, which is directly connected to it. Then router 3 forwards that acknowledgement to router 1. Router 1 forwards that acknowledgement to host A. Upon receiving the acknowledgement by this host A, assume that okay, 2 Mbps data received successfully. Then host A try to increase up to 3 Mbps or 4 Mbps. Correct? Maximum size is 10 Mbps maximum. So it may increase. Host A is increasing, suppose 4 Mbps to the power of 2, let us assume that 4 Mbps. So now 4 Mbps data transfer from host A to router 1. Then there is no problem. Input capacity is there. Then router 1 to router 3 to host, and this scenario continues. Then 2 to the power of 2 increase to 2 to the power of 3. That means 8 Mbps data. 8 Mbps data is transferring, so full capacity is there, so received. Then 2 to the power of 4, so 8 to 16 Mbps. When 16 Mbps is transferred, okay, is it possible? Because during the 3 handshaking only host A and host C know that only 10 Mbps data, correct? But if host A is sending, suppose 8 Mbps only, because it knows 16 Mbps is not possible because of 3 handshaking, they understand. So 10 Mbps तक ही भेज सकता है. So host A is trying to sending 10 Mbps data only. ठीक है? And that 10 Mbps goes via router 1, 1 to 3, 3 to C, and it is clear, right? But what happens in this case, while transferring the 10 Mbps data from host A to host C, during that time only, if host D also wants to transfer data to host B, the blue line. So कैसे जा रहा है यहाँ पर host D to your host 2, sorry, router 2, then router 2 to your router 1, and router 1 to your host B, correct? Router 1 capacity is 10 Mbps. Already 10 Mbps is coming from host A. D also wants to transmit the data to your host B via router 2. So D को किससे मतलब है? Only router 2 से मतलब है. Router A के router 1 के पास क्या है? इससे कोई मतलब नहीं. तो ये क्या कर रहा है? Host D is sending 10 Mbps. Suppose 1 Mbps for example. So that 1 Mbps goes via router 2. And router 2 forward that 1 Mbps to router 1. But already that input capacity is occupied by host A. So either host A's 1 Mbps data will be lost, or host D's 1 Mbps data will be lost, or some part of your host A's some Mbps data will be lost below 1 Mbps, means maybe 0.5 Mbps or something.
Data will be lost.
Lost. So if data is lost, means what happened?
Negative
acknowledgement. Negative acknowledgement means retransmission will be there. And if that retransmission increase again and again, there is no chance for the new packets, new data transfer. That means it as a sender assumes that there is a congestion in the network. So how to overcome that? So this condition says that in TCP, what is the approach? Sender increase transmission rate as first host here transmitted 2 Mbps, then 4, then 8. Okay? चल रहा है ना? Then as soon as these, that case problem for usable bandwidth, जैसे usable bandwidth कितना maximum 10 Mbps. So 2 से 4 को गया, 4 से 8 को गया, 8 से 10 तक जा सकता है, क्योंकि maximum capacity 10 है, भेज रहे हैं. Until loss occurs. So when A is sending the 10 Mbps data, during the same time D is also sending data, so there will be a loss. जैसे loss हो रहा है, immediately what it has to do? It needs to be decrease, multiplicative decrease. Okay? Why? Because of the loss of packet. जैसे 8 Mbps भेज रहा है, 10 Mbps भेज रहा है host A, उस टाइम पे लॉस हो रहा है, in that case it is the intimation to the host A that if you send transmitting 10 Mbps, then there will be a packet loss, so you better go to the previous stage only. So in the previous stage sending 8 Mbps, and now host D is sending 1 Mbps. Total capacity is 9 Mbps, which is handled by your router 1. So both the data can be transferred. So that is the meaning. Increase the packets or data transmitting until there is a loss. If there is a loss, go back to the previous stage, means multiplicative decrease. जैसे 10 से कहाँ पहुंच गए हम, 8 को पहुंचे, तो हम एक्चुअली 9 को पहुंचे, तो एडिटिव डिक्रीजिंग होगा. 10 को पहुंचे मतलब 2 पैकेट कम करके पीछे गया ना, 2 एमबीपीएस, तो मल्टीप्लिकेटिव डिक्रीज. Clear? So this is the meaning of the following this condition. Yeah, increasing and
CWNT.
I'll tell you. That is the congestion window size. CWND stands for, C stands for congestion, WND stands for window size. Okay. So what is the window size at the sender side? Maximum 10 Mbps. Correct? Maximum 10 Mbps. I'll show you the window size and the icon. Yeah. See, here the window size is, congestion window size is maximum, suppose 10 Mbps as in our example. So maximum size कितना रहेगा? 10 Mbps ही रहेगा. पहले वो 2 से गया, फिर 4 हुआ, फिर 8 हुआ, फिर मैक्सिमम 10 हुआ. जैसे लास्ट हुआ तो विंडो साइज में से घटा देगा, 8 को आ जाएगा. When sending the 8 Mbps also, at that time also if it is finding any loss, it will reduce to 4. Okay? During transmitting 4 Mbps also, if it finds any loss, it reduces to 2 Mbps. So that's the meaning, right? So now you check it out. What is happening in this? There is a time here in this graph, and here is the congestion window size. So at certain point, congestion window size is 10 Mbps, so it is starting with 2 Mbps, correct? Okay, assume that from here it is starting with 2 Mbps, and then this 2 Mbps, the additive increase window size means adding it, right? So क्या हो रहा है उससे? You can see it is increased, and then when it is going to, until the loss occurs, immediately it goes back to the downside. So it started with 2 Mbps, slowly increase. When there is a loss, it decreases its size, and again then it is start increasing until it find a loss. Whenever it finds loss, again it goes down. Okay, and this process continues until it completes its complete transmission from source to the destination side. Clear? Okay. What about online side? Is it clear for you? Ramesh? Is it clear? Yes, but okay. Yeah. Okay. No, let them. Okay. Which one? Here? Okay.
If host A wants to transfer data to host B, then it is possible via one router only.
Yes.
And the process will be same.
Host A can able to transfer data to host B, C, and D because they all are in the network.
Yeah, as there is no mark over here, so I am confused.
No, not like that. For example purpose, we have given host A is one source and host C is the destination. There is a possibility host A is source and host B is destination.
And
उसके लिए आप line ऐसे draw करो. You can draw host A is sending. Okay, sorry. So let me just clear here.
Okay, sir.
Now host A is the source and host B is the destination. ये line आ गया. Host A is the source, ठीक है? Host D is the destination. ये line आ गया. Host A is the source and yeah,
Host
host
is
C is already there.
C. We can change path also.
Anything, because anybody can send to anyone, no?
Yeah.
In the network, anybody can send to anyone. But for our example purpose, for understanding purpose, we treat that A is sending to C and D is sending to B, C is sending to A. Why? Because here say A is sending to C and C is sending to only A. What is that? In that transaction, when host A is sending data to C, C is sending acknowledgement to only A, not to D, right? Similarly, when host D is sending data to B, B only send acknowledgements to D. So that's why in that scenario it is clear. Clear? Okay, so that's the meaning of your the approach of your additive increase and decrease. Correct? Is it clear now?
Yes.
अब इसमें क्या होता है? The further way you can see what is the TCP slow start. So now only we just observe slow start and reach to the peak level and then come back. Okay. So in slow start, what happens when the connection begins between your host A and host B? First starting, it is sending one segment and waiting for the acknowledgement. Once acknowledgement comes, then it is increasing two segments. Then once those acknowledgements comes, then it increase four segments, 4 Mbps. Then once those acknowledgement comes, it increase to 8, then 16, then your 32, 64,
128,
and so on.
66.
So this increase will increase. This exponential increase will be there until there is a loss. So as soon as there is a loss, it reduces to half of its size. ऐसे मान ले अब ये क्या हुआ यहाँ पर 16 segments भेजे. So up to 8 segments transmission, everything is okay. Assume the positive acknowledgements are coming. So based on that, host A is assuming that okay, for 8 segments there is a positive acknowledgement. So now I can send 16 segments. So out of 16, maybe 1 or 2 may be lost, suppose, for example. But sender assumes that, oh, if I send 16 segments, there is a packet loss. So then reduce it to 8 segments. Clear? And then once it is reduced, half of the window size, congestion window size, from 16 to 8. From that point onwards, it allows the sender A to increase additively, linearly. That means 8 segments, next time increase 9 segments, then 10, then 11, and so on. So if 10 Mbps or 10 segments capacity is there, means it reduced to 8. Next transaction it goes with 9 segments, then 10 segments, then 11 segments. When 11th segment goes, there is a loss. So then your the sender comes to know that there is a possibility of loss. So I can send maximum only 10 segments. Yeah. So that is slow start method. When the connection begins, increase the rate exponentially until the first loss event happens. Okay. So initially the congestion window size is suppose the one maximum segment size, MSS means maximum segment size. Only one is going on. Correct. So then double the congestion window size in every round trip time.
Yes.
Every round trip time means for every acknowledgement. Okay. So done by increasing the congestion window size for every acknowledgement which is received. So what is the summary? Initial rate is slow but ramps up exponentially fast. Clear? So कब तक चलेगा फिर ये? TCP detecting and reacting to the loss. So what is happening? So the approach is reached until the congestion window set to a one maximum segment size, the window then grows exponentially as we saw in the previous slide. But loss indicated by 3 duplicate acknowledgement in that case, the duplicate acknowledgement indicates the network capable of delivering same segments. That means there is a packet loss is there. So congestion window size is cut in half window size as said. जैसे segment 16 को पहुंच गया, एक भी loss हुआ तो 8 को आ गया, ठीक है? So that is the solution. So TCP detecting the loss and based on that how it is reacting means reducing its size to half and from there it starts the linear increasing. Clear? Yes. So then the TCP is switching from slow start to your C, cumulative acknowledgement. Okay. So that's what we just observed, but it is showing in the graph itself. So with this, you can see that TCP congestion control, you can find whatever the example just we heard. This is given in terms of your number of segments. Slow start mechanism. What is happening in the slow start mechanism?
First transfer.
Yeah, first it transfers. Initially nothing is there, correct?
Yes.
Then it transfers one segment. Maximum segment size is 1. Then and that segment size is suppose you were 64 kilobits per second. In that case, it can find the acknowledgements and expecting the acknowledgement of 0. Okay. And if the duplicate acknowledgements comes means what?
Loss, packet loss.
Packet loss or retransmission is required. So usse kya hota hai ki suddenly it can reduce to half of this. So this is just the story of that one. Clear?
Yeah.
So this is the congestion avoidance one. Okay. So with this, these are bit in-depth one. This is not required for you. So with this, we can conclude your chapter 3. So I hope you might understand the concepts one by one, right? Yes, that's good. So now the time is 8:17. So good enough time we completed this one. I thought maybe because of the network problem we may not complete this, but it's okay. So online side, is it clear for you? Online side, is it clear for you? Okay then. So I would like to ask you to register your enrollment number in the chat box, and we'll stop the session now and have a nice day. If you have any queries, you are welcome to ask. If you have any queries, you are welcome to ask. They don't